The morning fog hung thick over the Norman hedgerows in July 1944 when Lieutenant James Morrison of the 2nd Northamptonshire Yeomanry first laid eyes on what would become the subject of heated debate among Allied tankers for the remainder of the war. His crew had just been assigned one of the new Sherman Firefly tanks, and standing beside it in the assembly area was a captured German Panzerkampfwagen Tiger II, what the Allies had begun calling the King Tiger. The massive German machine dwarfed Morrison's Firefly, its sloped armor gleaming dully in the early light, its long 88mm gun seeming to reach halfway across the field. It was, by every measurable specification, the superior weapon. Yet within weeks Morrison would write to his family that he would never trade his Firefly for anything the Germans had built, captured, or otherwise. This seemingly paradoxical preference would echo throughout British armored units for the duration of the war in Europe. To understand why requires us to look beyond the technical specifications that so often dominate discussions of military hardware and into the muddy, oil-stained, and frequently terrifying reality of mechanized warfare in the mid-20th century. The story of the Sherman Firefly versus the King Tiger is not simply a tale of two tanks. It is a story about reliability versus raw power, about logistics versus battlefield dominance, about the difference between what looks impressive in a factory and what actually keeps soldiers alive when shells are flying and engines are failing. The Sherman Firefly itself was born from desperation and British ingenuity. By early 1944, British tank crews had learned through bitter experience that their standard armored vehicles were woefully outmatched by German medium and heavy tanks. The Cromwell, while fast, lacked adequate firepower. The Churchill, though well armored, was slow and still mounted a gun insufficient for dealing with Tigers and Panthers at range. The Americans were supplying vast numbers of M4 Sherman tanks under Lend-Lease, but these too were armed with a 75mm gun that struggled against frontal armor of German heavy tanks. Enter Major George Brighty of the Royal Artillery. Working with engineers and facing significant skepticism from official channels, the British undertook to mount their excellent 17-pounder anti-tank gun into the turret of the Sherman. This was no simple task. The 17-pounder was a powerful, high-velocity weapon that had proven itself capable of defeating even the heaviest German armor when used in the anti-tank role. But it was also large, with a long recoil, and the Sherman turret was not designed to accommodate it. British engineers had to modify the gun, giving it a different recoil system and rotating the gun and its mount to fit within the available space. The result looked awkward, the long gun giving the tank a distinctive profile that would make Fireflies priority targets for German gunners. But it worked. By June 1944, Fireflies were being distributed to British and Commonwealth armored units, typically at a ratio of 1 Firefly per troop of 4 Shermans. The gun could penetrate the frontal armor of a Tiger I at reasonable combat ranges and could defeat a Panther's frontal armor under favorable conditions. More importantly, it could reliably penetrate the side armor of any German tank it encountered. For crews who had spent months feeling helpless against German heavy armor, the Firefly represented a sudden and dramatic shift in capability. The King Tiger, or Tiger II, represented the apex of German heavy tank design during the war. Development had begun in 1942, with the first prototypes emerging in late 1943. Production began in earnest in early 1944. The tank was a monster, weighing nearly 70 tons when fully loaded. Its frontal armor was 150 millimeters thick and heavily sloped, making it virtually immune to any Allied tank gun at normal combat ranges. The turret front was 180 millimeters thick. The long 88mm KWK-43 gun could destroy any Allied tank at ranges exceeding 2,000 meters. On paper, the King Tiger was invincible. In the minds of German high command, it would restore battlefield supremacy to the Wehrmacht's panzer divisions. In practice, it became something quite different. The tank suffered from chronic mechanical problems from the moment it entered service. The Maybach HL 230 engine, though powerful at 700 horsepower, was struggling to move a vehicle that weighed significantly more than it had been designed for. The Tiger II's power-to-weight ratio was actually worse than that of the earlier Tiger I, meaning it was slower and less agile, despite the more powerful engine. The transmission was a constant source of trouble. The 8-speed forward, 4-speed reverse Maybach Ulvar gearbox was a complex piece of engineering that required careful handling and frequent maintenance. In the field, under combat conditions, with inexperienced replacement crews, it often failed catastrophically. Final drives broke with alarming regularity. The overlapping road wheel design, inherited from the Tiger I and refined in the King Tiger, looked impressive but was a maintenance nightmare. If an inner wheel was damaged, crews had to remove multiple outer wheels to reach it. In the Russian winter, mud and debris would pack into the overlapping wheels and freeze overnight, sometimes leaving the tank immobilized until the ice could be chipped away or melted. Fuel consumption was another critical weakness. The King Tiger consumed fuel at a prodigious rate, managing perhaps 60 to 70 kilometers on a full tank under ideal conditions. In combat, with frequent starting and stopping, acceleration, and maneuvering, consumption increased dramatically. By 1944 and 1945, Germany's fuel situation was desperate. Synthetic fuel production facilities were being bombed around the clock by Allied air forces. Romanian oil fields, crucial to the German war effort, had been lost. Tanks sat immobile not because they were damaged, but because there was no fuel to move them. The King Tiger's massive appetite made it particularly vulnerable to this resource crisis. The Sherman Firefly, by contrast, was powered by reliable American engineering adapted to British requirements. Most Fireflies used the Continental radial engine, the same that powered standard Shermans. This was not a cutting-edge power plant. It was, in fact, based on aircraft engine technology from the 1930s. But it was reliable, well understood, and easy to maintain. More importantly, spare parts were abundant. The vast American industrial machine was producing Shermans by the thousands and Sherman parts by the millions. A broken engine could be swapped out in the field in a matter of hours. Transmissions, though not perfect, were straightforward and robust. The vertical vollet spring suspension was simple, effective, and easy to repair. When British crews first encountered captured King Tigers, there was certainly a sense of awe. Lieutenant Morrison's initial reaction was typical. Here was a machine that embodied raw power. Standing next to it, running your hand along that thick armor, understanding that your own tank's gun might not penetrate its frontal plate even at point-blank range, there was an undeniable psychological impact. Some crews wanted to try them out. Some intelligence officers wanted them studied. Some rear echelon officers thought they might be pressed into service. But frontline tankers, the men who actually had to take these machines into combat and keep them running under field conditions, quickly developed a different perspective. Captain William Blythe of the 1st Royal Tank Regiment spent 3 days with a captured King Tiger in August 1944. His unit had overrun a German position near Falaise, and the massive tank had been abandoned with only minor damage. Blythe's report, preserved in regimental archives, is illuminating. The tank was, he wrote, an impressive piece of engineering. The optical equipment was excellent. The gun was clearly capable of engaging targets at extreme range. The armor protection was, as advertised, extraordinary. But then came the problems. The tank had been abandoned partly because of mechanical failure, specifically a broken final drive. Blythe's fitters examined the damage and concluded that field repair would be impossible. The part would need to be replaced, and they had no spare. Even if they did, the repair would require specialized tools and several days of work. The fuel tanks were nearly empty, and when they calculated how much fuel would be needed to get the tank to a rear area for proper evaluation, the number was staggering. They had better uses for that fuel. More fundamentally, Blythe noted that the crew compartment, while spacious by German standards, was actually more cramped than his Firefly in several key respects. The turret, though impressively armored, was difficult for the commander to see out of. The gun, while powerful, had a slower rate of fire than the Firefly's 17-pounder due to the size and weight of its ammunition. Each round for the 88mm KW Conway 43 weighed over 20 kilograms. The rounds for the 17-pounder, while still substantial, were lighter and easier to handle. In a close-range engagement, where fractions of a second mattered, this could be decisive. Training was another crucial factor. British crews were trained on Shermans. They knew the vehicle intimately, understood its quirks and characteristics, knew how to get the best performance from it. The Firefly, despite its modified turret and different gun, was still fundamentally a Sherman. Drivers who had learned on standard Shermans could transition to a Firefly with minimal additional training. Gunners had to learn the characteristics of the 17-pounder, but the fire control system, the sighting equipment, the basic procedures were familiar. Loaders understood the turret layout. Commanders knew the vehicle's capabilities and limitations. A captured King Tiger, by contrast, was an unknown quantity. Everything from starting the engine to traversing the turret would require learning new procedures. The German instruction manuals, when they could be found, were naturally in German. Technical specifications used metric measurements and German terminology. Even if you could get the tank running and moving, could you maintain it? German and British tools used different standards. Spare parts would be impossible to obtain through normal supply channels. If something broke in the field, you would be stranded. Logistical considerations extended beyond the individual vehicle. The entire Allied supply chain was built around supporting specific types of equipment. Fuel, ammunition, spare parts, maintenance expertise, all flowed forward in an organized system. Fireflies fit seamlessly into the system. They used the same fuel as every other Sherman, the same tracks, the same engines, the same basic components. Ammunition for the 17-pounder was being produced in quantity and shipped regularly to forward units. Armored workshops had fitters trained on Sherman maintenance. Recovery vehicles designed to tow disabled Shermans could handle a Firefly without difficulty. Attempting to integrate captured King Tigers into this system would create complications at every level. The tank used different fuel specifications. Its ammunition was obviously incompatible with Allied guns. Its weight exceeded the capacity of many Allied recovery vehicles. Maintenance would require German-trained mechanics or extensive retraining of Allied personnel. For a single tank, or even a small number of tanks, these obstacles might be overcome for evaluation or propaganda purposes. But as operational vehicles in a frontline unit, they would be a logistical nightmare. Combat experience reinforced these practical conclusions. In the autumn of 1944, as Allied forces pushed toward the German border, encounters with King Tigers became more frequent. The massive tanks were being deployed increasingly in defensive roles, using their superior armor and firepower to anchor strong points. British tankers developed tactics to deal with them. The goal was never to engage a King Tiger frontally if it could be avoided. Instead, Firefly crews worked with infantry and other armor to maneuver for flank shots, where the King Tiger's armor was more vulnerable. The 17-pounder could reliably penetrate the side armor at combat ranges, and even a near miss might damage tracks, optics, or other external components. What became clear through repeated engagements was that the King Tiger's theoretical advantages often failed to materialize in actual combat. The tank's size made it difficult to conceal. Its weight limited where it could go. Many bridges and roads simply couldn't support it. Its slow speed meant it could be outflanked by faster Allied tanks working in coordination. Its fuel consumption meant it often couldn't relocate to respond to changing tactical situations. And its mechanical unreliability meant that for every King Tiger encountered in combat, several more were sitting broken down behind German lines. Lieutenant Morrison's unit encountered a working King Tiger in September 1944 during fighting near Arnhem. The German tank was positioned at a crossroads, covering the approach to a bridge. Morrison's troop, consisting of 3 standard Shermans and his Firefly, was tasked with finding a way past it. Direct assault was out of the question. Instead, they worked with infantry to identify a covered approach along a tree line. While the other Shermans and supporting infantry created a diversion, Morrison maneuvered his Firefly into a position where he could engage the King Tiger from the side. The engagement lasted perhaps 90 seconds. Morrison's gunner fired 3 rounds. The first struck the King Tiger's turret side, penetrating and detonating inside. The second hit the hull side. The third was unnecessary. The German tank was already burning. Morrison later wrote that the theoretical invincibility of the King Tiger meant little when you could put a 17-pounder round into its side armor. What mattered was having a tank that could get into position to make that shot and then reliably extract afterward. The Firefly's mobility, while not spectacular, was adequate. Its reliability meant that when he needed to move, it moved. Its integration into British tactical doctrine meant he had the support needed to execute the maneuver. The winter of 1944 to 1945 brought the Ardennes Offensive, Germany's last major attack in the West. King Tigers were deployed with several units, including the 501st Heavy Panzer Battalion. They achieved some local successes, but the offensive ultimately failed for many reasons, including supply shortages, Allied air superiority once the weather cleared, and mechanical breakdowns. Captured German documents and post-war interviews revealed that mechanical failures had removed more King Tigers from action than Allied fire during the offensive. Transmissions seized, engines failed, final drives broke. Tanks that began the offensive ready for action were abandoned by their crews when they could neither be repaired nor recovered. British Fireflies, meanwhile, fought throughout the winter with relatively few mechanical problems. When issues did arise, they were generally addressed quickly. Frozen water in the cooling system could be thawed. Track thrown in the mud could be replaced with tools and parts available in the field. Engines that wore out could be swapped. The tank might not be glamorous, and it certainly wasn't going to win any one-on-one duel against a King Tiger under ideal conditions, but it kept fighting. The psychological aspect of this reliability cannot be overstated. Tankers going into combat needed to trust their vehicle. They needed to know that when they pressed the starter, the engine would catch, that when the driver shifted gears, the transmission would respond, that when the gunner triggered the main gun, it would fire, and the recoil system would function properly. This trust was built through experience, through seeing the vehicle perform day after day, through having breakdowns be manageable rather than catastrophic. Crews assigned to Fireflies developed this trust. They learned their tank's individual quirks, the way every mechanical vehicle has its unique characteristics. They knew that their particular engine ran a bit rough when cold, or that the turret traversed smoothly except for one specific arc where it caught slightly. These were knowns, predictable factors that could be worked around. The alternative, taking a captured enemy vehicle with unknown maintenance history, unknown quirks, and no reliable source of spare parts or technical support, was unconscionable to men whose lives depended on their tank's performance. There were, admittedly, areas where the King Tiger genuinely excelled and where the Firefly could not match it. Long-range gunnery was one. The King Tiger's optical rangefinder and stabilization system, when working properly, allowed engagement of targets at distances where the Firefly would struggle to score hits. In open terrain, on the Eastern Front, or in certain parts of France, this range advantage could be decisive. A King Tiger in a prepared position with good lines of sight and adequate support was a formidable obstacle. But these ideal conditions were increasingly rare as the war progressed. The fighting in Northwest Europe in late 1944 and into 1945 was often in close terrain villages and small towns, forests and hedgerows, places where engagement ranges were measured in hundreds rather than thousands of meters. In such conditions, the King Tiger's range advantage evaporated, while its size and weight became liabilities. It couldn't move through narrow streets as easily, it couldn't position itself in buildings or behind small terrain features. It consumed fuel, moving short distances at rates that would have taken a Firefly much farther. The Firefly's 17-pounder, while not equal to the German 88 at extreme range, was more than adequate at the ranges where most tank combat actually occurred. It could defeat the side and rear armor of any German tank. It could penetrate the frontal armor of Panthers under many conditions. Against Tiger Is and King Tigers, flanking shots were effective, and the Firefly's mobility relative to these heavy German tanks made achieving flanking positions feasible. Ammunition supply was another practical consideration. The 17-pounder fired several types of ammunition, including armor-piercing, discarding sabot rounds that were particularly effective against sloped armor. High-explosive rounds were available for infantry support. The variety of ammunition and its steady supply meant that Firefly crews could adapt to different tactical situations. Captured King Tiger crews would be limited to whatever German ammunition they happened to have or could scavenge, with no reliable means of resupply. Maintenance rhythms and schedules were deeply ingrained in British armored units. Crews knew that certain maintenance tasks had to be performed at specific intervals. Daily maintenance included checking fluid levels, inspecting tracks and running gear, cleaning weapons, and performing basic services. Weekly maintenance was more extensive, including oil changes when needed, more thorough inspections, replacement of worn components. These rhythms were built around the Sherman platform. Introducing a completely different vehicle would disrupt these patterns and create uncertainty. The specialized training that British fitters received focused on Allied equipment. These were the men who kept tanks running, who diagnosed problems and performed repairs under field conditions, often under fire. They were experts on Sherman engines, transmissions, and running gear. They knew the common failure points and how to address them. A King Tiger would be an exotic puzzle, requiring different knowledge and different tools. Even simple tasks like changing a track routine on a Sherman would be complicated by the King Tiger's overlapping wheel design. Recovery and evacuation procedures were another consideration. When a tank was disabled but repairable, it needed to be recovered to a maintenance area. The British Army's recovery vehicles were designed to tow Shermans and similar weight vehicles. A King Tiger, at 70 tons, exceeded the capacity of most recovery equipment. Special arrangements would be needed, perhaps multiple recovery vehicles working together, or specialized heavy equipment that might not be readily available in a forward area. A disabled Firefly could be hooked up and towed to safety relatively quickly. A disabled King Tiger might have to be abandoned. Combat effectiveness, ultimately, depends on availability. A tank that breaks down frequently or requires extensive maintenance is not available for combat. A tank that cannot be resupplied with fuel or ammunition is not available. A tank that cannot be recovered when damaged is lost to the unit. The Firefly's great strength was its availability. Barring combat damage, it could be expected to be operational day after day. Maintenance could be performed efficiently. Repairs, when needed, could usually be completed without extended downtime. This reliability translated directly into combat power that could be sustained over time. By contrast, the King Tiger's impressive specifications translated poorly into sustained combat effectiveness. German records show that operational readiness rates for King Tigers were consistently low. At any given time, a significant percentage of available tanks were non-operational due to mechanical problems, lack of spare parts, or lack of fuel. The tanks that were operational had often been cannibalized for parts to keep them running. This is not to say that individual King Tigers, when properly maintained and supplied, were not effective weapons. They certainly were. But they were effective in isolated cases rather than as a reliably available combat tool. The cultural and institutional factors surrounding the two tanks also played a role. British tankers were part of a military tradition that valued pragmatism and getting the job done with available resources. The emphasis was on effectiveness rather than theoretical perfection. If a Sherman with a 17-pounder gun could do the job, that was sufficient. There was no particular desire to field the biggest or most impressive tank, only to field a tank that worked and that allowed crews to accomplish their missions and survive. German tank design, by contrast, had increasingly emphasized heavy armor and powerful guns, creating vehicles that were impressive but impractical. The Tiger I had already demonstrated this trend, being a formidable weapon but plagued by mechanical complexity and supply requirements. The King Tiger took these characteristics to an extreme. It was as if German designers believed that technical superiority alone could compensate for Germany's deteriorating strategic position. In practice, the opposite proved true. Simpler, more reliable Allied tanks that could be produced in quantity and kept running in the field were ultimately more effective than smaller numbers of technically sophisticated but temperamental German heavy tanks. Post-war analysis by both British and American military historians would confirm what frontline tankers had concluded through experience. The Firefly, despite being essentially an improvised solution, had been one of the most effective Allied tanks of the war. Its combination of adequate armor, good mobility, excellent firepower, and, above all, reliability made it a weapon that crews trusted and that commanders could count on. The King Tiger, despite its fearsome reputation, had been less effective than its specifications suggested, undermined by mechanical problems, supply shortages, and the practical realities of mobile warfare. Lieutenant Morrison survived the war and eventually rose to the rank of major. In his memoir, published in the 1960s, he reflected on his time in the Firefly. He admitted that the first time he saw a King Tiger, he had been impressed and even envious. But after months of combat, after seeing King Tigers abandoned with mechanical failures, after watching German crews desperately trying to preserve fuel, after tallying which tanks were actually available for combat day after day, his perspective had changed completely. He would not have traded his Firefly for any number of King Tigers. It was, he wrote, like comparing a reliable tool to a temperamental work of art. One got the job done. The other was impressive to look at, but frustrating to use. The crews who fought in Fireflies throughout northwestern Europe in the final year of the war developed a particular affection for their tanks. These were not perfect machines. The long gun made the tank easily identifiable and drew German fire. The armor was adequate but not exceptional. The interior was cramped. But the Firefly showed up for work every day. It started when you needed it to start. It moved when you needed it to move. It fired when you pulled the trigger. In the chaos and terror of mechanized combat, where so much was uncertain and beyond your control, this reliability was precious beyond measure. There is a broader lesson here about military technology and effectiveness. The best weapon on paper is not always the best weapon in practice. Raw specifications, armor thickness, and gun penetration and horsepower tell only part of the story. The full picture includes reliability, maintainability, logistical requirements, integration with existing systems, training requirements, and sustained operational capability. A weapon that excels in all of these areas while being merely adequate in raw performance may ultimately be more valuable than a weapon that excels in performance but struggles in the practical aspects of military operations. The German military learned this lesson painfully. Resources that went into developing and building complex heavy tanks, like the King Tiger, might have been better spent on more numerous medium tanks with better reliability. The famous German engineering quality, which had served the country well in peacetime, became a liability in wartime when conditions demanded simplicity, mass production, and ease of maintenance. By 1944, Germany needed weapons that could be built quickly with available resources, maintained by inexperienced personnel, and operated by hastily trained crews. The King Tiger was none of these things. The Allies, particularly the Americans and British, had learned different lessons from their pre-war experience and early wartime setbacks. American industrial practice emphasized standardization, interchangeable parts, and designs that could be produced in vast quantities by semi-skilled workers. The Sherman embodied these principles. It was not the best tank in any single category, but it was good enough in most categories and excellent in the categories that mattered for sustained operations: reliability and availability. British modifications to American designs, like the Firefly conversion, showed the value of practical improvisation. Rather than demanding an entirely new tank design, British engineers worked with what was available and improved it where necessary. The result was not elegant, but it was effective. This pragmatic approach, focusing on solving immediate problems with available resources rather than pursuing theoretical perfection, served the Allies well throughout the war. The experience of tank crews in Northwest Europe in 1944 and 1945 demonstrated conclusively that in mechanized warfare, the weapon you can count on is worth more than the weapon that looks impressive but fails when you need it. Tankers in Fireflies knew they were not driving invincible machines. They knew that German heavy tanks had thicker armor and sometimes more powerful guns. But they also knew that when they went into action, their tanks would perform. That knowledge, born from experience and reinforced by reliable machinery, gave them confidence. And confidence in combat can be as valuable as armor plate. The story of British tankers preferring their Fireflies over captured King Tigers is ultimately a story about the difference between theory and practice, between specifications and reality. It is a reminder that in military affairs, as in so many areas of life, reliability and practicality often matter more than raw power. The tank that runs is better than the tank that sits broken down, no matter how thick its armor. The tank that can be supplied and maintained is better than the tank that requires specialized support, no matter how powerful its gun. The tank that crews understand and trust is better than the tank that impresses observers, no matter how sophisticated its engineering. This lesson, learned on the battlefields of northwestern Europe in the final year of the Second World War, remains relevant. Military planners still face the temptation to pursue ever more advanced and capable weapon systems. The trade-offs remain the same: raw performance versus reliability, sophistication versus simplicity, capability versus availability. The tankers, who preferred their Fireflies over King Tigers, understood these trade-offs instinctively, not through abstract analysis, but through lived experience. They knew what mattered when shells were flying and engines were running and lives hung in the balance. In the mud and blood and chaos of combat, what mattered was having a machine that worked. The Sherman Firefly, humble and improvised though it was, did exactly that. It showed up, it performed, it brought crews home. No amount of armor or gun power could replace those fundamental virtues. The British tankers who fought in them understood this completely. That is why, given the choice between their reliable Fireflies and captured complex King Tigers, they chose reliability every time. It was not about pride or patriotism or anything abstract. It was about survival and effectiveness, the most fundamental concerns of anyone who goes into combat. And on those grounds, the choice was clear.